6.4. Now I might be thinking, wait, Ms. Frickman, we just did 6.1. Why are we doing 6.4? Well, we're going in between 6.0, 6.4 because together they kind of make 6.4, 6.0 and 6.1. So whenever we have radicals, which we've talked about, we have this index right here. That index becomes a fraction exponent. The index will be the denominator of the fraction exponent. So square root of 36 is 36 to the 1/2. Cubic root, because my index here is 3, would be 64 to the 1/3. Fourth root of 16 would be 16 to the 1/4. Now, when I'm looking at these problems, you can do them one of two ways. You can either rewrite this as the cubic root of 216, and both of these I can put in my calculator. Hey, glare. So I can either go 216 and then either go to the raised to button is right there. And then you should put in parentheses 1 divided by 3, parenthesis. Or you could go to math, which I showed before, and do the cubic root of 216. Both ways, you get 6 as your answer. Here, I can apply my properties of exponents, in which you will have to start doing. So my base here is 7. With the exact same base, I don't do anything with the 7s. I can add my exponents. Since I'm multiplying here, I'm going to add my exponents. So this becomes 7 to the 1st. You can always check by using your calculator. I have 7 to the 0.5 times 7 raised to the 0.5. Still gets me 7. What if I have something like this? Well, I can rewrite this as the 4th root of 5 times the 4th root of 125. I cannot multiply these. These do not have the same base. 5 and 125 are not the same base like they were over here. So I can multiply 5 times 125, and I get the 4th root of 625. Because these indexes are the same, you can only combine when the indexes are the same, like here. I can multiply them through. So I have the 4th root of 625, or else I can go 625 raised to the 0.25, so that's 1/4. Or go to math, or actually do your 4th root, go to math, type 5, 4th root of 625. Both of them, I get 5 as my answer. Here again, you should try to do this one by yourself. Okay, so I have 11 as the same base, so I can do 1/2 plus 1/2. That'd be like 11 to the 1st, or just 11. I can rewrite this. This would be when I want to rewrite. This would be the square root. You don't need the 2 there, but square root always has a 2 of 64. And 8 times 8 fell on the floor, picked it up, and it was 64. These bases are not the same, but both of these have the indexes the same. So I can rewrite these as the square root. And because both of these are square roots, because there's no number here, there could be a 2 there, I can multiply those together. Square root of 36, which is 6. So now, the key concept here is when we have a fraction exponent, like so, the denominator right here is always my index. If you have a fraction exponent and there's a number on top, that number is your exponent. The denominator goes out in front, the number becomes your index. Why did I tell you that? Because if I were going to rewrite this in radical form means I'm going to have a radical. Remember, this right here is a radical. This is my index. So if I'm going to rewrite this first one, my index here is 7, because that's in my denominator, and the x cubed stays out in front. Here you have to be careful. So I'm going to rewrite y, the negative 3/2, as negative 7/2. Negative 3/2 is the same thing as negative 7/2. The negative has to stay with this 7. So this would be equal to the square root, I don't have to put a 2 there, of y to the negative 7, which is the same thing as the square root as 1 over y to the 7th. You do not want to have negative exponents. So this right here would be my final answer. Actually, kidding. I could actually simplify this. So it would be the square root of 1 over the square root of y to the 7th, which would be 1 over, square root of 1 is 1. There are 3 groups of 2. So I can take out 3 full y's, leaving me with 1 y here. So if I have 1, 2, 3, 4, 5, 6, 7, here's a group, here's a group, here's a group. I can take out 3 y's and 1 y would stay inside. What about this? What if I want to rewrite this in exponential form? My index here is 2. So my a would be raised to the 5/2 power. Whatever your index is your denominator. So my index here is 5, and my exponent would be 3. So b to the 3/5. You should pause and try to do the other ones by yourself. So my w, the negative should go on top. So this would be 1/8 root of w to the negative 5. So in this case, it would be my 1/8 root of 1 over w to the 5th, because you do not want negative exponents. For 2/10, it would be the same thing as 1/5. So I write that as a fraction exponent. What if I don't know the fraction? Well, on your calculator, you can type in your decimal, go to math, and then you can change it to a fraction. Frac is changing to a fraction. So it's saying change this decimal to a fraction, and it will give you what the fraction should be. So my denominator is 5, so it would be my 5th root of x. You can have a 1 here if you so wish to. So again, if I want to rewrite this as exponential, there should not be a radical sign. So my x, my index here is 4, so that's my denominator. For my y, my index here is 5, so that is my denominator. What is the difference between radical and exponential? Radical has that symbol. Exponential is whatever your base is raised to the exponent. So exponent for exponential, you have to have a radical sign for radical. Last but not least, the final page. How can I write these in simplest form? Well, I first had to change these into exponents. When I change them into exponents, this top one will become x to the 3/4, and on bottom, this becomes x to the 2/8. And now, even though my indexes are not the same, since my fraction exponents, I can use exponential properties. So I'm going to take the top minus the bottom. So in this case, I can do 3/4. So I personally just like to do it as a fraction, subtract the 2/8. If I get a decimal, I go to math, and I change it to a fraction, to the 1/2. So this is going to give me x to the 1/2. I have a radical as my beginning answer. I should end in a radical. So this would be my final answer. Here, my indexes are not the same. I cannot multiply these. So this is going to become 3 to the 1/3 times 3 to the 1/4, because my index here is 3, index here is 4. My base stays the same. I add my exponents. Base stays the same, add the exponent. So 1 divided by 3 plus 1 divided by 4. I don't know what that fraction is. Math, fraction, 7/12. So this is be 3 to the 7/12. So I'm going to rewrite that because I started with a radical. So my index here is 12, and I can leave it as 3 to the 7th. You can also multiply out 3 to the 7th. You should pause and try to do these last two by yourself. On top, this would be x to the 3/2, and bottom x to the 2/3. So it becomes x 3/2 minus 2/3, which would give me x 3/2 minus 2/3. Math, fraction, 5/6. So when I rewrite this, my 6 is my index. The 5 stays under. And finally, for this section, this becomes 7 to the 1/2 times 7 to the 1/3. Again, my base stays the same. I'm adding my exponents. So 1/2 plus 1/3 would give me 7 to the 5/6, which would be the 6th root of 7 to the 5th. Simplifying with rationals. So I can rewrite this, or else I can actually just type these into my calculator. I can go 16 raised to the negative 2.5, just like that. Push enter. I don't know what that is. I'm going to try to put that in the fraction. So this answer would be 1 over 1,024. You have to make sure to type it in exactly how it's written. So I have negative 32 raised to the 4/5. That'd be a positive 16. You should try to do the next two by yourself. 16 raised to the 3/4 would give me 8. 9 raised to the negative 3.5. Again, don't know that fraction. 1 over 2187. But what if we don't have just a number like that? What if we actually have exponents too? I can rewrite 8, and I'll go more of this into class, but you should get to know your properties or your powers of 2. So negative 8 is the same thing as negative 2 cubed. X to the 1/2 is the same, or to the square root is the same to the 1/2. So what I did from here to here is rewrite my 8 and rewrite to my 1/2. I can now do or simplify inside first. So I'm going to keep this as negative 2 to the 3rd. This will become x times x to the 1/2, y to the 1/2. This is still to the 2/3 power. These two can combine. Since these are multiplying, I can add my exponents. So this would be x to the 3/2, y to the 1/2, and to the 2/3. Now, to finalize it, I can do my power to a power to each one. Negative 2, when I have my 3 to the 2/3 power, this becomes negative 2 squared. 3/2 times 2/3 would give me the first, and this y would give me 1/3. So my overall answer would be negative 2 squared is 4. Here's my x. To rewrite this would be a cubic root of y. 16 can be rewritten as 2 to the 4th. So now I can add my power to a power here. This will become 2 to the negative 3. This will become a positive 6. This stays on top because my exponent here is positive. This stays on top, but my y to the 3rd has to move on bottom. Sorry, that should be the 6th. And then I have 8. 2 cubed is 8. And the last two, so I can rewrite 8 as 2 cubed. I can do my negative exponent. This becomes 2 to the negative 1. 3 times negative 1/3. This becomes x to the negative 5. Both of these are negative. Both of them have to move to the bottom of the fraction. I still need a 1 on top to make it a fraction. And finally, I can rewrite 9 as 3 squared. This becomes y to the 1/4. And again, my power to a power, you can't be greedy, got to give to everyone on the inside. This becomes 3 to the 3rd, x to the 3/2, y to the 3/8. Now this one's a little bit more tricky when I rewrite it. I'm going to rewrite this as 27. I'm going to take out 1x. There's 1x here. I'm going to rewrite this x as 1/2 is the same thing as 4/8. There would be 1/2 x left over here. The reason why I do that is because when I rewrite this in a radical format, these have to have the same indexes. So this would be 27x. My index here is 8. That's why I had to rewrite this 4 to the 8th, because of this 1/2. I took out 1 here. I'm left with 1/2. 4/8 is 1/2. This would be x to the 4th, y to the 3rd. Man, that was a lot, Ms. Frickin. This is confusing. Yes, I understand that, but we will be going over it in class also. You have a great day.